If you do not have your, or if you do have your properties and sets of real numbers display, if you have that with you, it's ready, you just have to turn it in. There's a file that's displayed back there. I'll be going through those for the next week or so, and we'll get those hung up. There's some really pretty ones. I was looking through some of them before, but get some of those hung up and get those in the grade book for you. And they are right there. Okay, so I think number 1 is negative 11. And number 2, I think, is negative 24. So on and so forth down the list there. The last one is x equals negative 2. So please be checking your answers. So, how are we doing? Do you have any questions? Any questions at all? Come on. If you missed even one of them, even just one little thing, or I've had people over the years that got them all right, but then they said, you know what, I got number 3 right, but I was a little shaky. Why do I do this, or why shouldn't I do that? Ray, what do you think?
On number 2, what are we supposed to do first? Are we supposed to times the 5 to the 4 and the 2, or times the 4 and the 2 first?
Great question. I'd say in PEMDAS, we want to do the work inside parentheses first. So
Does that mean you do everything inside the parentheses and then times
you
it
might
by
have to
5?
do a little bit of ordering within the parentheses too.
Okay.
So I would say, I clearly would just start off with 7 minus 5 parentheses. If I was going to do this one, I'd look in the parentheses there and I'd say, well, I've got an absolute value of negative 11, and I've got 4 times 2. I would probably do the 4 times 2 on the same step that I did the absolute value of negative 11. So I would say 4 times 2 is 8, minus, what's the absolute value of negative 11? 11. Okay, so if I were doing this one, I would probably start with something like that.
And then do you minus the 8 by the 11?
Yeah,
And
there's
then
still
you
work to be
times the
done.
5?
Nope. So let's talk about that. So 7 minus 5, what's 8 minus 11? Negative 3. So would it be fair to say that at this point in PEMDAS, I've done all the work that could be done inside parentheses? Like there's no more adding or subtracting or multiplying within the parentheses, right? So P is done, what does S stand for in PEMDAS? I got to do exponents next. So I'd say before I did anything with this 5, I need to handle the exponent. Right there. So what's negative 3 inside parentheses squared?
9.
It's 9.
6.
9. You're doing 3 plus 3. Yeah. So it's 9. It's positive 9, right? Okay, so that would be 7 minus 5 times 9 plus 14.
Okay, but you're still timesing the 5.
Yeah.
Okay.
Yep. After you do all the
That's
work in
right.
parentheses, it's still 5 times the result of whatever that was. Finish it off real quick. 5 times 9 is 45 as I continue on with PEMDAS. And at this point, I would just go from left to right. 7 minus 45 is negative 38 plus 14. That's where I came up with that final value of negative 24. Thanks for asking. I genuinely appreciate that. Anybody else? A thought, a comment, maybe on number 3 or...
Could you go through number 3?
Yeah, for sure. Let's go through number 3. So number 3 says simplify completely. So what simplify completely means is that we want to get all of our terms that are like terms and get them combined as much as possible, right? And so as I look through this, I think what terms are like terms, and I got to be honest, at first it's a little bit unclear, right? Do y'all see the 2 distributive properties that are within this?
Negative 5 and 6.
Yeah, negative 5 is getting distributed, 6 is getting distributed, so I need to handle those first when it comes to simplifying. So I will distribute the negative 5, and that would give me negative 10 plus, right, because a negative times a negative is a positive, 5x. And then I would also distribute the 6. This would give me plus 6x squared minus 18. That make sense so far?
Yes.
Okay, so I've done the distributive properties. Then what I need to do is ask myself, are there any terms that are like terms that I could add together and combine to make this a little more simple? So when I first look at this, I'm just going to go from left to right. I'm going to highlight the negative 10 in red and ask myself, is there any other term in there that's like negative 10? The 18, the negative 18. Yeah, that's right. So I would say those two terms are like because neither of them has a variable, right? They're both constant. What's negative 10 plus negative 18?
Negative 20.
It's that negative 28 you saw in the answer. Okay, so then I would move on to the next term and ask myself, okay, 5x, positive 5x is the next term. Is there any other term in here where that is like this 5x?
6x.
Sometimes we're tempted to say that, but we have to be honest about this and say, while this is an x, this is different. This is x times x, right? It's x squared. And so because of that, I would say that 5x and 6x squared, because of the squared, are not like terms, actually. So I'd say the 5x, there's nothing to combine with that one. And then you can kind of see by deduction that there's nothing to combine with the 6x squared either. So you just leave as is. That's as simple as you can get. If that did happen to be 6x, if it was different, couldn't you add 5x plus 6x? Like, so if it was 5x plus 6x, what would you get if you combine those together? 11x. The way I like to think about that is if you have 5 x's and you add 6 more x's, how many x's do you have? You have 11 x's, right? So 11x. Was that a good enough explanation?
Yeah.
Okay. Just so you guys know, like the explanations always sound pretty good in my head, because sometimes things get lost in translation, so I'm not going to be sad or offended if you say, no, I'm still not understanding. It's okay. Anybody else? How'd number 4 go? That was the newest of the things in our review. Newest item in there. All right. Anybody else? Comment, question of any kind? Okay, so I wanted to draw your attention to one thing here real quick before we get moving on with what we're going to practice with today. We're going to be doing equations again. We're going to be using a lot of these same skills. I want to just remind you about the concept quiz retries. Had lots of folks, like 4, 5, 6 people just the last couple of days come by and say, I want to do a retry. And I'll say, hey, do you have your retry assignment? Do you have your, you fixed your quizzes? And I kind of get this blank look like, what are you talking about, right? So I want to say it again. I'll keep saying it until I feel like we all have it. The way that you do a concept quiz retry, I would say if I were you, my first thought would be, is my homework complete? So if you look through your homeworks and you have missings, to me that'd be the first thing I would do is I'd go through and take care of those missings, because you've got to have your homework complete in order to do a retry, right? You can't have a bunch or even just like 1 or 2 missings and do a retry. So homework has to be complete. A lot of you are doing okay with that. Some of you need to get some things complete. Number 2, what you need to do is, and again, this makes a lot of sense to me. Like if you mess something up, doesn't it make sense for you to go back and try and fix it? So whatever you missed on your quiz, go back and retry it. See if you can get to that right answer and say, oh my goodness, I finally get it. Because your quiz retry is going to look just like your original quiz. It'll just have different numbers. And so if you can master that original quiz and fix the things you need to fix, I'm guessing that retry quiz will go better, right? Last thing you got to do, can anybody tell me? It's the last thing. You got to do 3 things to start your retries.
You have to do the retry assignment.
Yeah, the quiz retry assignment. So I'm going to call it CQRA. So you got to do the concept quiz retry assignment, and all that is just extra practice. Like think about it. Like if I'm a basketball player and in a game on Friday night, I shot some free throws. Let's say I shot 10 free throws in the game, and I only made 4 of them. I would be disappointed in that, right? 4 out of 10 is not that great for free throws. Should make more than that. Wouldn't it make sense that, like over the weekend or over the course of the next couple of weeks, I would stay after practice and shoot 100 free throws, or shoot until I can make 7 in a row or something like that? That's all that is. That's just extra practice to get you back up to speed. Hopefully, I'm happy to help you with those things. I'm happy to help you with all this stuff. Does that make sense? Any questions? I'll leave that up. But I so encourage you to go through that process. It'll make you better. It'll make your grade better. It'll make you and your parents happier. It'll make everybody happier. It's a win-win-win for everybody, right? You got to take that step. One other note real quick as I transition over to what we're going to do today. I sent out a personal email to about, 3 or 4 folks about lunch today. One second, sorry, don't forget your question. About lunch today. And I just wanted to extend that invite to every single person in the class. If you are struggling with maybe some of the Unit 1 concept stuff, right? The concept 1 through 4, I'm going to get your concept quizzes back to you today. And you just want to work on some stuff, just get out some whiteboards or work on the big whiteboard or just get some extra practicing. It's a personal invitation from me. I'm gonna go down, I'm gonna grab my lunch, and I'll come back up. I'll be back up here in like 10, 15 minutes or so. Please, come in. Let's just work together, right? I mean, you get sort of a long lunch every day, maybe, like you can hang out with your buddies anytime you want. Let's take a day or two here and make sure that as we ramp up for our Unit 1 test, that you are, prioritizing what probably should be prioritized. So, question, Brent.
If we missed homework, how do we do it?
Email me and say, I didn't do Unit 1 homework 11 or whatever, and I will open that back up for you, and then you do it. So, yeah, if you request an extension through WebAssign, I just want to tell you right now, I don't look at those because there's like 7 or 8 of us that use that, and the sheer number of extension requests, it's like, it would be pages and pages, and I got to go through and be like, not mine, oh, there's Bray, okay, so which one that would be my full-time job. So just send me a quick email, I'll get it in, and you're good. You're welcome. Anybody else? Okay, beautiful. So we, again today, are going to be working on solving equations, okay? So solving equations is a key concept, key skill here in Algebra 1, and so we're going to be using a lot of the same ideas that we did last time. We're going to be doing a little bit of simplifying on the front end. So hopefully this will help our simplifying skills as well. So let's jump in. Let's try 1 or 2 of these, and I'll have you guys do some practicing. I'll get your concept quizzes back to you, and hopefully we'll all have a happy day. Okay, so here we go. Practice 1. So I want to give you a second. For those that don't have the Unit 2 packet, I'm going to print some of those off and bring those to you tomorrow. There's a decent number of you that could use that. Write down number 1. Write it down as is. Says solve 7x plus 9 minus 3x equals 12. Okay, so the word of the day for us as we work on these equations is going to be this. We are going to need to be doing simplifying before we solve. Simplify before we solve. So if there's any like terms that can be added or other various simplifyings that we could be working on here, we want to do that before we solve anything. So I don't know how you guys feel about this. I'm kind of on the fence about this. I'll do it here. I'm going to just draw like a little line right through the equal sign, trying to illustrate that all the stuff on the left side is on the left side of the equal sign, and the stuff, just a 12, on the right side is on the right side of the equal sign. The equal sign kind of like a fence, right? And we need to be careful about crossing over that fence. We need to do it the right way. Okay, so on the left side of the fence, do you all see any simplifying that we could do? 7x and 3x, those are like terms, aren't they? When we add them up, what do we get? So 7x and negative 3x, right? So when we add 7x plus negative 3x, what do we get? 4x, that's right. So it'd be 4x plus 9 equals 12. So I'm going to just try to keep that equal sign right on the fence there. You guys see any other simplifyings that we could do on the left side? Any other like terms to add or anything? 4x plus 9. You see any simplifying we could do at all? This is where you say no, Mr. Anderson, or yes, definitely. What do you see? No? I agree. There's no more simplifying to be done. So we're going to try to solve for x. Based on what we did last week, or maybe some of your experience in the past, what would you guys suggest would be a good first move to start getting the x by itself?
Subtract 9.
Subtract 9 from both sides, yes. So I'm going to subtract the 9 from the left side of the fence and subtract the 9 from the right side of the fence. Of course, she's using the additive inverse property, right? The subtraction undoes addition. So once we've done that, Trevor, what would be the result?
3.
So, okay, equals 3. How about the left side?
4.
4x equals 3. Okay, fantastic. We're not all the way there yet, though, right? We need to get the x by itself. Oliver, what would you do to try to get the x by itself here in the end?
Where did you get 4x?
Hang on just a second. Oliver's going to answer this, and I'll get you.
Divide by 4,
Yeah. Why would you divide by 4?
because multiplication on the left.
Yeah, it's 4 times x. And so how do you undo multiplication?
What?
How do you undo multiplication?
Division.
Division. So that makes perfect sense what you said. So Mason, a second ago, you said, where did we get 4x? We got that at the start when we recognized that 7x and minus 3x were like terms. So we need to simplify before we solve. So any like terms that can be combined or added up, we want to do that before we even think about solving. So Oliver has led us right to the end here, right? The x is now by itself. X equals 3/4 would be my final answer. You guys did a lot of the heavy lifting there. Questions? Questions on any piece of this? I would say this would be the minimal amount of work. I think I've shown all the steps. You guys gave some really good steps here. I think I've written down all the steps that you'd need to write down to show that, yes, indeed, I know what I'm doing. Okay. Any questions at all? All right, fair enough. So I think then number 2 might be within your grasp. So if you would, please take a look at number 2. I'll reset the screen here in a second, but take a look at number 2, 5 minus 2, parentheses, ... and see if you can solve for the variable, see if you can solve for u. So Ellie, I'm kind of curious. What was your first step? I don't know what you're going to say. I have not peeked at your paper.
I distributed the -2.
Whoa, did you hear that? Say that again so the video can hear you.
I distributed the -2 to you.
Oh, what a great idea. So when you did that, you got 5, keep going.
5 parentheses -2u plus 6 and parentheses.
I'm not a fan of the parentheses, to be honest.
Yeah.
I like your distributive property.
I just kept it in.
I don't think we want to, actually. So if I wrote this is what I heard you say. I would say that this is not so good. I would say, and I'm going to make a blanket statement here, like anytime you fully complete a distributive property, I really think you should get rid of the parentheses. I think there's potential for confusion there. So I would say, if you did 5 minus 2u plus 6, I think this makes a lot of sense. Keep going. Sorry, I talked over you.
9u equals 7.
Nice. Okay. I think Ellie has led us in a really nice direction here. That distributive property, and she did the distributive property nicely. I think this makes a lot of sense. Okay. So, are there any other simplifications that could be done on that? I didn't make my fence. Let me make my fence. It's going to be sort of a bendy fence. There we go. Okay, so on the left side of the fence, see anything that could be further simplified? Sophia?
You can combine -2u and 9u.
Hey, those look like terms, don't they? Does that make sense? What do you get when you do that?
I got 7u.
Okay, so 7u. I like it. How about the 5 and the 6? Are those like terms, or do they need to stay separate? They're like terms. What's 5 plus 6?
11.
Okay, so still doing okay? I heard a wait. Go ahead.
Why wouldn't you put the 11 in front of the 7u?
You could. So if you had 7u plus 11, or if you had 11 plus 7u, it's actually the same thing. So this is the commutative property of addition. And so with addition, you can change the order around, and it really doesn't matter.
Okay.
You could go either way, and you could be totally successful. That is a great example of an awesome question. He's like, wait, I thought it had to be this way, but you wrote it that way. Does this make sense? Right? All he is doing is he's sorting it through in his mind, trying to make it make sense for him. You should be doing the same thing if you have a similar thought. Thanks, Sebastian. Okay, so Doc, what do we do? Trying to get the u by itself, and it's clearly not yet by itself.
Then we subtract 11.
Don't we subtract 11? Do we that? Yeah? Yes. I think that makes sense.
Yeah. So subtract the 11 by the 11, and then the 7 on the right side.
Fantastic. What results when I do that?
-6?
Oh, you're looking at the right side?
Or -4, my bad.
Okay, so -4. And then what would the left side look like?
7u equals -4.
Okay, perfect. All right, so we've done a lot of good simplifying. We started solving. We're not quite yet done with the whole solving part. Chase, how would you finish this one? Any ideas?
You would divide it by 7,
Why?
because the opposite of multiplication.
Good answer. Perfect sense. So we divide both sides by 7. That makes the u go by itself, so you'd get u equals -4/7. I'm seeing quite a few of you doing this with your heads and thumbs up a little bit. But you have any questions? You guys supplied a lot of really good steps there. All I did was sort of write it down for you. You guys came up with some good steps. Solid for sure. Okay. I'm ready to move on if you are, but if you have a question. I want to go back. Like Sebastian's question was so good because I don't know if you caught this or not. He said, wait, I thought it should be like this, but you wrote it like that. Is that okay? If you have like what you feel might be either a misconception or maybe you feel like maybe I might have written something down in a confusing way, you got to ask. Got to ask. Super proud. Thanks. Cool. Okay, so it looks like you're good. Move on to number 3, but I want to do this one with you. We'll kind of see how this stands, and we'll finish up our class with a few other examples as needed. So take a look at number 3. Take a look at number 3. If you need to write it down, write it down. It says solve 5y plus 11 equals -3y plus 27. Okay, I drew in my little fence there. Anybody identify what's so different about this one than the other two we've looked at so far? We see Julia.
There's y on both sides.
Do you see that? She's right. This is different than the other ones. There's a y on the left side of the fence, and then there's a different y on the right side of the fence. So I'm going to tell you this right now. If you have a situation where you've got a variable, like a y in this case, one on one side of the fence, the other on the other side of the fence, one of the things you're going to need to do in this process is you need to have one of those jump the fence to get with the other one. Okay? You need either one of them to jump over to the right side or the other one to jump over to the left side. But at some point in here, we're going to need to simplify in that way. We need them to join up. Okay, so which one do you guys want to move to the other side of the fence? You have an idea? What do you think, Julia?
Don't you always have to move the y first?
Well, I agree. We need to move the y term.
Yeah, don't you always have to move the y that was attached to it first?
Depends on if there's a distributive property. There could be some mitigating circumstances where that might not be the best move. I would say in this situation, that is the right move. I agree. But how would we do that? Like, what do you guys propose? Like, should I try to move that 5y over to the right side? Or should I try to get the -3y over to the left side, right? Because we have a choice. Sasha, what do you think?
I think you should add 3y.
Okay, why did you pick that?
So it's positive.
A lot of people will go with this, and I think this makes sense. We rarely, if ever, drop plus signs. But how many times have you ever heard somebody, maybe yourself, say, I dropped a minus sign, I lost a minus sign, right? For some reason, we lose those. I don't know why exactly. Sasha's idea of hey, let's get more positive things involved rather than negatives. I think that makes sense. So I'm going to have that -3y jump over the fence by adding 3y to both sides. So, Bray, what would happen if we did do what Sasha suggested? What would that left side of the fence look like?
The left side?
Yep.
Well, then if you carry the 5y over there.
The 5y is already on the left side, right?
Oh, then you take the 11, so it would be negative 11.
You're trying to solve. I don't want you to quite solve yet. I just want you to look at that left side. I just added 3y over there.
Oh, 3y plus 11.
Well, but the 5y was already there, right?
Sorry, 8y plus 11.
There we go. So 8y plus 11. Does that make sense to you guys? I can see that that just made sense to you.
Yeah, sorry.
I just maybe wasn't
I was
very
looking
clear.
at 3y and then over the lines, and I just,
Sure.
that's what I had.
'Cause we're adding
8y plus
vertically.
11, Yeah,
Yeah. And then that, Bray, what would that equal if I kept on going?
it would be plus, well, equals 27.
Equals 27. Okay. So that's kind of our unique step here, right? As was pointed out, Julia said, hey, there's a y on the left side, there's a y on the right side. We need to handle that. Sasha said, why don't we just add the 3y to both sides? You came up with the result. Can you guys try to finish this one?
Yeah.
See if you can take it home from here, okay? You got 8y plus 11 equals 27. So take a minute and see if you can finish this one out. Get to a good place, okay? Looks like a lot of you have already done that. Something's coming. I know you wrote 8 equals 4.
Oh, that's
Well, that's a y. Okay, gotcha. I was like, I gotta say, Doc, I don't think that's true. She's giving you some good advice. That's making sense. Good job. Okay. So, Anya, what'd you do first as you tried to solve this one? Okay, so Anya suggested this. Y'all okay with that strategy? Okay, so if I did do that, Noah, what results on the left side if we did what Anya said?
8y.
And on the right side? Okay, then Sydney, how do we finish?
Then you divide each side by 8.
Why? Like W-H-Y, sorry.
You get y1.
Okay, but why did you choose to divide? Instead of like subtract or add or something.
So you have to divide.
There you go. Perfect. And we're just using all those properties that we talked about before to help us solve these. So y then equals 2. I hope that's a happy result for you all.
Yeah.
What do you think? Good? Okay. So, nobody's saying anything? All right. Let me just do a little thinking here. I'm going to say, have you noticed that there's lots and lots of practices?
Yeah.
Tons of them. I put a lot of these in here on purpose so that you will have plenty of opportunities to practice above and beyond what we absolutely have to do. So here's what I want to do. Let's finish off with this one. We might do one more depending on how this goes, but this could be our last one. We'll just see. So would you flip over to practice 2, number 2? It's this one right here. Practice 2, number 2. So of course you can all see this is no longer an equals, right? It's no longer an equation. It's one of these inequalities, right? We did one of these last time. It's where we have to do a little number line graph of the answer. So see, this is going to be a really good one. We're going to be able to talk about a lot of things. So see if you can get the x by itself. Let's just start there. See if you can take this inequality and get the x by itself. And then we'll go from there. Questions, Sebastian?
So would you just, if,
I'm going to get your drink. You just keep talking.
so is this like the other one where you would just treat the,
Like a fence?
Yeah, like a
Yeah,
fence.
so I'd put a fence right through that inequality. Okay. So Sebastian was talking about this.
yeah,
With a fence, right?
yeah.
Yeah, I agree.
Divided by 14 and
This is a negative 5x. But, yeah, your original question on what I just added, the 3x over, yes, that's exactly right. Plus 3x on here. So, the way you determine that is look at your inequality, right? In this case, it's, like less than or greater than or whatever. If that inequality has a little orient to it, you're using extra e. So you fill in a circle with extra e, right? If it does not have the orient to, just draw the arrow in what you feel is less than or greater than. Circle. Yep, that adds up to be 0, right? If I've got a negative 3x's, and I add that to positive 3x's, I have no x's.
Just
10 of them. Yep. And now that you've got the x's together, which you did a good job of, now our goal is to get the x all by itself. You obviously get the negative 4, you get the negative 2 there. It's a matter of trying to make those two correct. Does that make sense? Okay. Okay, I'm going to try to catch up to you guys. How many of you noticed right away that there was an x term on the right side and an x term on the left side? Right, you notice that? Ellie, what'd you do about that?
I added 5x, so I did the one on the left side.
Very interesting strategy.
I did it because then if I added 3x to the other side, then it would still be a positive.
Okay, so how many of you did what Ellie is suggesting? How many of you added 5x to both sides? Interesting. So hold on, Ellie. I think it's a bold and good strategy. I want to illustrate something different because as I walked around, I saw that the majority of folks did the other thing, but I think we're going to come to agreement in the end. Is that okay? Mm-hmm. So if I wasn't going to add 5x to both sides, what did the rest of you do?
Add 3x.
You added 3x, and that's okay. I think that is just as good of a strategy as Ellie's. There will be some interesting steps along the way, though. So I want to do it that way. That's all right? Okay. So I'm going to go plus 3x to both sides, and I'll add my like terms here. So on the right side, would you guys agree that all I have left over is a 10?
Yes.
Yeah.
Okay, so on the right side, I've got a 10. On the left side, did you guys get this? Negative 2x
Yes.
minus 4. That make sense so far?
Mm-hmm.
Okay, so now my goal is to try to get the x by itself. Did you guys get rid of the negative 2 first, or did you get rid of the negative 4 first?
4.
Negative 4 is the right way to go. How would you get rid of minus 4?
Add 4.
Plus 4, right? So I'd add 4 to both sides. So it'd be plus 4 plus 4. So this would give me, this is where this one gets interesting, so don't check out on me on this one. Did you get that? Now, the final step, if we did it this way, now Ellie's way is pretty nice because she avoids this final little tricky step. But if we got to here, there's one last step left that's a little on the tricky side. I need to get rid of the negative 2. How do I do that?
Add 2.
Divide. Not divide by 2. Divide by negative 2. And you guys might remember this from middle school. But if you have inequalities and you divide both sides by a negative, I have to do something special, Sasha?
You have to flip the equality.
Flip the inequality. Right, so watch what happens here. On the left side, I get an x, and on the right side, I get a negative 7, right? Because I divided by a negative, which you can see here and here, because I divided by a negative, that inequality symbol in the middle, instead of going the way that it was, needs to go the other way. Needs to flip around. Please don't pack up yet. I know we just hit our time. What kind of circle do we draw on the negative 7, open or close? It's open on negative 7. And the arrow goes which direction? Left or right?
Left.
Goes to the left because we want less than. Negative 7. For those interested in the interval notation, which you need to be able to do for WebAssign, this would be parentheses, negative infinity, comma, negative 7, parentheses. WebAssign will get picky about that. I'm going to hand back your concept quizzes so that you can do any retries you need. I'll get those to you on the way out so you guys can pack it up and go. And I'll just get those to you as you leave.